is the shape of a liquid? Answer is very familiar to you. That is, it is the shape of container occupied. So container occupied. Therefore, liquids do not have definite shape. Do not have definite shape. Then observe some examples. If we drop a mercury liquid on the floor, what happened? Yes, it does not flow. It does not flow, and it is split into as droplets. How are droplets? Droplets as they form spherical. They form spherical bead shape. Spherical bead shape. Instead of flowing on the surface, split into droplets. Droplets have spherical bead shape. Next, observe soil at the bottom. Soil at the bottom of flowing river. As they are not in fused form, they are not stick together, as they are separated. But not stick together. Where? At bottom of the river. Yes. Why this has happened? Yes. If you touch liquid to the surface with the help of capillary, what will happen? Yes. Third example is liquid rise or fall. When rise or fall in a thin capillary, where in a thin capillary, this is very, very important, touches the surface of a liquid. Why this has happened is explained with the help of phenomenon known as surface tension. Surface tension is the phenomenon cause towards these properties previously we discussed. Clear? Yes. Observe here. Take a container. Yes, liquid is like this. The particles in the bulk is attracted equally by surrounding molecules. Equal attraction Yes, this is molecule at the bulk. Liquid molecule at the bulk. How does it happen? Attracted in all directions. Attracted in all directions. But the molecules near the surface area, molecules near the surface area surface molecule or molecule at surface, molecule at surface. Microscopic, we are talking about microscopic property of the matter. Molecule at a surface is net attractions into the liquid. Net attractions. How are net attractions? Net attractions, yes, like this. This is a net attraction downward. And what is the experience they got? What is the experience they got? Yes, they have more energy. More energy. These molecules have more energy. More kinetic energy. In order to reduce the energy, they are coming close. Yes, the particles are like this. If you observe, the particles are like this in a liquid. And here, what is noticed, dear students? The molecules are compressed, and this is surface film. This is surface film, and continuous random motion. They are in random motion. As it is surface film. As due to more kinetic energy than bulk, because bulk, the particle is equally attracted. Okay, so they are compressed. They are compressed, or they want to minimize energy, minimize kinetic energy. So they are coming close. They are coming close, and they want to reduce. Yes. How is it happened? Minimize the kinetic energy by compressed. Due to compression, surface area is surface area is minimized. Surface area is minimized. Okay, that's why what is the information? Mercury liquid becomes spherical shape to minimize surface area. Minimize surface area. Here also they are not stick together, they are coming outside. If you remove from the bottom of the river, then they stick together. But here they are separated in spherical shape. Here also same information, and this is due to surface tension. In surface tension, what is happened? Surface area is minimized. Therefore, what is surface tension? Surface tension is defined like this. The tension of the surface film, the tension of the surface film of a liquid caused by film of a liquid caused by the attraction of the particles in the surface by the bulk which tends to bulk of liquid which tends to minimize surface area. Why surface area is minimized? Kinetic energy is more. To reduce the kinetic energy, and they have forces applying downward. These are the reasons. As after that, we have to take some information. Yes. Surface energy. Energy required to increase surface area of liquid by 1 unit is known as surface energy. Surface energy units, as energy is expressed in joule and area expressed in meter square. Joule per meter square is the answer. Yes. And surface tension is expressed in gamma. Yes. So gamma is equal to surface tension is equal to force acting per unit length. Force acting per unit length. Yes. What are the units in SI units? SI units are, as force is taken in Newton per meter. Newton length, unit length per meter, Newton per meter. Yes. And what are dimensions to surface tension? Dimensions that is gamma. 2 is kg per second square. Yes. So this is the information towards surface tension. One more property of liquid will be explained. Yes, magnitude of surface tension. Magnitude of surface tension. How does it depend? It depends on attractive forces, which is directly proportional to attractive forces. More attractive forces, more surface tension, and more spherical in shape. Attractive forces, then surface tension is inversely proportional. This is point 1, and this is another one, surface tension, which is inversely proportional to temperature. As temperature increase, what will happen? Energy is more. If more energy is there, in order to reduce the energy, then they come into spherical shape. These are the 2 points towards surface tension. After that, we shall move to another property of liquids. Viscosity is another one. Viscous liquids, viscosity. Yes, what is viscosity? That is, yes, it is a measure of, resistance to flow. Why? Because the particles have mobility to flow, which arises due to the internal friction between internal friction between layers of fluid, that is a liquid, in the immediate contact of surface. With immediate contact. Okay, this is the definition, and what is the information related to this one. Yes, this is expected as layer of a liquid. Then it is moving with velocity u, and it is stationary. Yes, this is plate or layer of a liquid which is stationary, and another one is over this one. It is moving very fast. Yes, this is another layer moving on this one, and it is with moving velocity u plus some extra velocity, small increase in the velocity, that is du. Small increase in velocity, and the area of the plate, this is area of the plate, and this is the distance between two layers. dz is the distance between two layers. Third layer is like this. This is third layer, and this is opposing the flowing of the above layer, so therefore its velocity is u, and some resistance. Yes, what is happening? Some resistance is happening, that is with lowering of some velocity du. Okay. Yes. After this information, what is the mathematical relation? Yes. Then there is one term possible to take, that is a laminar flow. What is laminar flow? Yes, laminar flow is regular gradation velocity. Regular gradation velocity is passing from one to next layer, one layer to next layer, one layer to next layer. There is regular gradation velocity is called laminar flow. Okay, then we shall move to another one. Let's take what is velocity gradient. Velocity gradient is given by a formula: small change in the velocity divided by the distance between layers. This is called velocity gradient. As a force is required, a force is required to maintain the flow of layers. Maintain the flow of layers. Then the force is already you know very well. Force is directly proportional to area of contact. Area of contact. Force is also directly proportional to velocity gradient. Velocity gradient is a gradient. Velocity gradient. So velocity gradient is here defined, and that is nothing but force is directly proportional to, yes, that is nothing but laminar flow, velocity gradient or laminar flow. Then that is du by dz, and this is area which is given by A. By combining these two, we have a formula. This is 2, this is 1. By combining 1 and 2 equations, we got force F is directly proportional to area of the contact, and also directly proportional to velocity gradient or laminar flow, that is du by dz. As after removing proportionality, we will have a proportionality constant, that is, as the proportionality constant is eta, into remaining things, area of contact into velocity gradient du by dz. This is the final relation about force. So therefore it is a coefficient of viscosity coefficient of viscosity. Clear? Then the SI units. SI units as Newton, Newton second per meter square. Yes. 1 Newton second meter square is equal to 1 Pascal second, that is equal to kg per meter per second. Yes, this is another relation for commutative point of view. Yes, viscosity is, as you increase the temperature, what will happen? As temperature increases and the one layer is flowing over other layer of liquid is very more and viscosity is less. So therefore viscosity is inversely proportional to temperature. Okay, that you have to maintain, dear students. And one more point is to be taken.